In this section, we will explore sequences. A sequence is a list of numbers that is following a particular pattern. In this video, we will learn some types of sequences and how to generate them. We will first introduce sequences through an example. Then we will describe two types of sequences called arithmetic and geometric progressions. Finally, we'll go through a simple algorithm to generate them. Can you guess what's the next number in the list? If you have guessed 25, then you are correct. As you can see, the way to generate the next number in the list is to add 4 to the previous one. What you see here is an example of an arithmetic progression. The scope of this section is to build a basic framework to be able to generate different types of sequences. Using imperative languages, the above sequence can be implemented using traditional loops. We will later see alternatives to these. Arithmetic progressions are the easiest to understand. We already saw an example of them in the previous slide. Here you see another example. To generate these sequences, it's very simple. We grab an item on the list and add a difference and produce a new number. In this example, we have 1 add 3 resulting 4. 4 plus 3 is 7. 7 plus 3 is 10, and so on. There is also a more mathematical way to generate these. It involves numbering each item in the list by its index, starting from 0. We can then use this formula, a plus n times d, where a is the starting number, in this example a 1, n is the index that we want to generate, and d is the difference, in this case 3. If we try to work it out for n equals 3, we can substitute and get a result of 13. In contrast to arithmetic progressions, geometric use multiplication instead of addition. Here you can see an example of geometric progression with a ratio of 7. To build this particular sequence, we grab the first item in the list, 4, and multiply it by 7. The result is 28, and we repeat the operation again. 28 times 7 gives us 196, and so on. We can also do the same trick as before, assign an index to the sequence starting from 0, and use this expression to generate any item we want. Here, A is the first item in the list, just like before, R is the ratio, and N is the index we want to generate. If we try working it out for n equals 3, the result will be 1372. Now that we have a background on the two types of sequences, how do we go about generating them in our code? Let's have a look first at our arithmetic progression. We define our function, which takes in a start number, a difference, and the total number of items to generate. We start by creating an empty array of size total. The same array will be returned at the end of our function. Making use of a loop, we go from 0 to total. In each iteration, we copy into the array the value of the start variable. The start variable is updated in each iteration by adding the difference. At the end of the loop, the array should be full with our arithmetic sequence. To generate a geometric progression, the algorithm is almost identical. Instead of using the difference, we use a ratio. And instead of adding the difference, we simply multiply the ratio to the latest value. We can further simplify our algorithms by using our maths formulas. For example, we can generate a geometric progression array by having the same loop, but instead of continuously updating the last element, we use the expression, substituting for the ratio and the start value. As you can see, this is not rocket science. The idea is to use these simple sequence generators to introduce new tools in functional Scala.